welcome to this score booster series of ACE Engineering Academy. Already you had a session. So today is a communication system. We are taking one topic every day or one subject every day. In other words, heat transfer is done. So today I am going to take communication systems. These are the other subjects that will be taken per each day, 1 hour session, and this program is trying to focus on the major areas where you can expect the questions and trying to focus on those things which are very, very important. So telling you the most important things, just a practice of little bit questions. It's just like a brush up of what you have already studied. So let us go through this part of communication systems. As you know, this is first time added in electrical engineering department. So most of the students are little bit frightened of how to prepare for this subject. So because it is first time added, the advantage you will have is the questions that you will be getting will be at a very fundamental level. So don't get panic. Cover all the topics that are there in the syllabus. That is the most important thing, because even one bit can completely change your life. The posting can change your life. So in competitive exams, especially job giving exams, time bounded exams, you need to be very focused, concentrating on each and every part of your syllabus, because the questions can come from any corner of the syllabus he has mentioned. Okay, so let us go through this communication part today. So myself, my name is Servan Kumar. I am faculty at ACE Engineering Academy for both online as well as offline platforms. I take communication systems here. Along with that, I also take signals and networks, but my major priority is for communication systems. Now, these are the topics that are there in your syllabus. The total syllabus, whatever he has mentioned, I have divided into topics. So, basic signals and their transforms, basic signals and systems part, because without this you cannot understand the remaining part of the topic. So, what are the basic signals, what are the transformations, what are the basic systems, and how are they represented in Fourier plane? Then what is a block diagram representation of analog communication system, standard amplitude modulation scheme, double sideband suppressed carrier modulation scheme, single sideband suppressed carrier modulation scheme. So all these three comes under amplitude modulation schemes. And then we have frequency modulation and phase modulation. These come under angle modulation schemes. Okay. And then we are having a little bit of study of noise characteristics and receiver properties. Then we are having a digital communication part. Only the pulse code modulation is there in your syllabus. Okay. And a little bit on TDM and FDM systems. So this is how the total syllabus is framed. I am expecting around 3 questions from your total syllabus. So one question from these amplitude modulation schemes, one question from this angle modulation schemes, and one question from this digital communication part, and maybe one question from the fundamentals. So maximum 3 to 4 questions can come, and the focus will be in this way. That is what I strongly feel. Okay, so the questions will be most of the times formula based. Try to remember all the formulas for all these modulation schemes and straightforward substitutions only. There may not be very difficult questions that might be coming from these areas. And this is how I concentrated the classes for both online as well as offline batches. Signals and systems, the fundamental part I have taken 5 hours, and the total analog communication part, means covering all the amplitude modulation schemes and angle modulation schemes, is 10 hours, and digital communication scheme is 5 hours. So totally around 20 hours of dedicated learning for these communication systems. That is enough, because you have to concentrate on the remaining subjects also. So fairly this part is enough. And these are the question areas where weightage can come. So basic signals, the transforms, and when you see all the modulation schemes, power calculations and bandwidth requirements, and then digital communication, the bandwidth calculations. So these are the areas that we'll be focusing on. So today, this 1 hour session, I will be concentrating on entire analog communication part. different amplitude modulation schemes we have, and different angle modulation schemes we have, along with the fundamentals of signals and systems. So whatever the important things that are there in this part, I will be covering that, and we will see around 4 to 5 questions on each topic. That will complete today's sessions. So if possible, there is any other chance, I will take one more session pertaining to only digital communication, because in 1 hour session, we may not be covering the entire part. So let us make this session a very productive session. I will list out all the important points. I will not explain, I will not derive. We will only list out the important things and see what are the important questions that are focused on that particular area, right? Let's proceed with that part. Now, from this basics of signals. So here you have the basic signals. Basic signals are del of t, impulse function, then DC signal. You have exponentials, e power minus at u of t, e power at u of minus t, e power minus a mod t. Now, let us try to write the transformations for this, and I will go to the next page. So, for del of t, the Fourier transformation we have is 1. And for 1, the Fourier transformation is del of f. These are all standard transformation pairs. So, very simple part, try to understand. For e power minus at u of t, we have 1 by a plus j into 2 pi f. And when you are replacing t with minus t, we will get e power at u of minus t, replace f with minus f. So, you will get 1 by a minus j into 2 pi f. So, e power minus a mod t is just adding the above two signals. So, when you add signals in time, you will add signals in frequency. So, you will get a 2a by a square plus omega square. So, these are all standard functions: impulse, DC, exponential functions, real exponentials, two-sided exponential function. Then, if you subtract these two functions, you will get signum function. We write it as Sgn of t. Subtraction of signals in time is subtraction of signals in frequency. So, you will have 1 by j into pi f. Or you can also express this as 2 by j omega. Okay? And Fourier transformations for standard periodic signals like cos functions and sine functions. So, for capital A cos omega cos 2 pi f naught t, it is a by 2 del of f minus f naught plus a by 2 into del of f plus f naught. Impulses occurring at f equal to f naught with area of impulse as peak amplitude divided by 2. And similarly, we also have for capital A sine 2 pi f naught t. This is a by 2j into del of f minus f naught minus a by 2j into del of f plus f naught. Okay. So, these are the Fourier transformations for periodic cos and periodic sine. Both are very important transformations. Okay. This is how we can relate the basic signals and their transformations. Now, coming to the next one, these two are very important and you can expect a question on this: rectangular and sinc functions. So, when you have a standard rectangular function, how you can find its Fourier transform? So, when you take x of t as capital A into RECT of t by capital T. So, this is a rectangular function which you are defining in time domain. So, very simple, when you sketch this function, it is a rectangular pulse on both sides of 0 with the total duration of capital T seconds. So, it should be from minus t by 2 to plus t by 2, whose amplitude in this interval is capital A. So how to write the transformation for this function? So immediately you can write transformation as sinc function. So you can write directly as sinc f. Now the coefficient of this f will be total width of your time domain function, which is capital T, and the coefficient of this sinc function will be total area. Base is T, height is A. So area of a rectangle is base into height, A into T, finish. So this is how directly you can write the transformation. So this is very important because suddenly in between they will ask you to find the bandwidth related things, these type of questions. So you have to convert from rectangular to sinc and sinc to rectangle. So once you have a rectangular function in time, you can write it transformation as sinc. If you have a sinc function in time, you can write the function as rectangular in frequency. Both are interchangeable. And we also have triangular and sinc square functions. Triangular and sinc square functions. So if you have a triangular pulse in time domain, suppose let us assume I am considering a symmetrical triangular pulse from minus t to plus t, whose amplitude at 0 will become a square capital T. Then what is its Fourier transform? If you have a symmetrical triangular pulse in time, it is sinc square function in frequency. So first write sinc square f. Now the coefficient of f is half of the width of time domain signal, which becomes a capital T. And coefficient of sinc square function is total area. What is the area? You can write this as two right angle triangles. Half into base is T, height is a square T. So it becomes a square T square. One more is there. So it is totally a square T square. So this is how you can write for a triangular pulse in time, its transformation will be sinc square function in frequency domain. So these two are very, very important for us. Rectangular and sinc functions and triangular and sinc square functions. Is it clear? And other than this, we also have standard Gaussian pulse, e power minus pi t square, for which the transformation would be e power minus pi f square. So this is one special signal for which time domain and frequency domain representations are same. Gaussian pulse in time is again Gaussian pulse in frequency. And if you take a scaled version of Gaussian pulse, means e power minus bt square, then if you take its Fourier transform in omega plane, you will have root pi by b into e power minus omega square by 4b. So this is also one very important function. Okay, so these things you have to remember: rectangular sinc, triangular sinc square, and scale version of a Gaussian pulse. These three transformations will give you a lot of edge in competitive exams. Okay. Now, if you take the basics of systems, these are basics of signals. Different signals I have taken and their Fourier transforms. So no need to do any derivation of these things. Just keep in mind what are these transformations. They become very, very handy for you. Okay. Now if you take the basics of systems, so we have different systems we use very frequently. One of the important system is a Hilbert transformer. So what is this Hilbert transformer? It is also called as a minus 90 degrees phase shifter. So this system does not affect your amplitude response. It will have effect only on phase response. That is the most important point. So the impulse response of this Hilbert transformer is given as 1 by pi t. And if you take its representation in frequency domain, it is Sgn of f divided by j. So if you sketch its response in frequency domain, so signum function by j in frequency, so amplitude is 1 by j for positive frequencies and value is minus 1 by j for negative frequencies. So this is how you can represent its h of f. So what are the properties of the Hilbert transformer we have? If you take a Hilbert transformer, means the impulse response of the system that I am considering here is h of t equal to 1 by pi t. Okay. So if you give any input to the system, what does this system going to do? So basically if you take the mod of h of f, because mod of 1 by j or minus 1 by j is 1 for all frequencies. And what is angle of h of f? 1 by j angle is minus 90 degrees for positive frequencies and it will be plus 90 degrees for negative frequencies. In real time, we will be only concentrating on the positive frequencies. So that is the reason we are also saying that it's a minus 90 degrees phase shifter. So if you give input as x of t, y of t will be Hilbert transformed signal, which is x cap of t. That is a representation. So how you can tell the output easily? For the given input signal, you add a phase of minus 90. The output you are going to get is a Hilbert transform function. Now because it has no effect on amplitudes, it has no effect on energy. That means the amplitude of the output signal will be equal to amplitude of the input signal. And the phase at the output will be equal to the phase of the input added with the minus 90 degrees for all positive frequencies. Because amplitude spectrums are not changing, the energy of the output signal and energy of the input signal will remain same. So these are all the points related with the Hilbert transformer. So because it is having that effect of minus 90 degrees on input signal phase, this is considered as a very important and a crucial system. So that is the first system that we need to understand. Now apart from this, we also use filters. Ideal low pass filter. So whenever you take a low pass filter, we assume that its cutoff frequency is FM hertz. So FM represents the maximum frequency of your message signal. And the passband gain of this filter is considered as 1. So this is how we represent h of f of an ideal low pass filter. So when you pass any signal through this filter, what is the meaning? It will pass the signal components which are having a frequency which are less than or equal to FM hertz, and it will multiply the amplitude with 1. So that is the meaning of an ideal low pass filter. So low pass filters are filtering your message signals. That is the reason these are generally used at the last stage of receiver. So these are used at last stage of receiver. Okay. And the other system we are going to use very frequently is an ideal band pass filter. So these have higher as well as lower cutoff frequencies. So when you represent a spectrum, we have to represent on both sides. So that is the reason we draw the representation on both sides. So the default gain is 1. So they have higher cutoff frequency as well as lower cutoff frequency. So generally this is represented as center frequency Fc, and lower cutoff frequency can be Fc minus Fm, and higher cutoff frequency can be Fc plus Fm. This is just an example that I am taking. Generally they are identified by lower as well as higher cutoff frequency. Okay. So this is how we can represent an ideal band pass filter. So these are identified by center frequency, which is generally represented as Fc hertz, and also bandwidth. bandwidth is nothing but the difference of this FH and FL. So in this example, it is 2 into FM hertz. And they have an amplitude response or a passband gain which is equal to 1. So these are the characteristics of band pass filters. Now because these are filtering high frequency component and transmitting only the components well within this interval, these are used at the last stage of transmitter. Sorry, used at last stage of transmitter. So these are two very important systems that we use, one at the transmitter side and the other at the receiver side, band pass and low pass filters. Now other than this, the system that we talk most commonly is a modulator. So in general, we carry out this process of modulation. So here we take a message signal m of t. So whenever we write message signals, these are low frequency, baseband or band limited signals. So whenever you consider your message as baseband, band limited or low frequency signal, we have the spectrum of the signals maximized to a frequency of FM hertz. So by default, this is the spectrum that we consider. The maximum magnitude is assumed to be 1. So this is how we take the spectrum of a message signal. Now what is process of modulation? It is simple product of your message signal with a very high frequency carrier signal. So this is called as a very high frequency single tone carrier signal. So generally the value of FC we take will be many times greater than FM. FM will be in the order of kilohertz and FC will be in the order of megahertz or gigahertz. Now whatever the product you are getting is called as a modulated signal, represented as S of t. That's all. So in general, what is modulation? It is a process of multiplying a message signal with a carrier signal. So what is happening here? You are multiplying S of m of t with AC cos 2 pi FCT. That's all. So this is what we refer to as modulation in general. So what is a modulated signal in frequency domain? You will have multiplication in time is convolution in frequency. So m of f convolved with AC by 2 del of f minus fc plus AC by 2 into del of f plus fc. So you will get a S of f as AC by 2 you can bring outside m of f minus fc plus AC by 2 into m of f plus fc. Simple. So these things already I have given the formulas. I am just using them, that's all. So if you draw the spectrum of the modulated signal, means S of f, how does it look like? You are shifting the message signal right side by fc times. So that message signal spectrum will now get centered about fc. And values will be from fc minus fm to fc plus fm. And the peak amplitude would become AC by 2. Finish. Now the same spectrum is also shifting left side by fc, m of f plus fc. So the same message signal will now get centered about minus fc. Values will be from minus fc minus fm to minus fc plus fm. This peak amplitude would become AC by 2. So this represents the spectrum of the modulated signal. Clear? So what is happening now? Whatever the signal that you are taking as message is a low frequency signal. Correct or not? Because this FM is maximum in the order of hertz. But whatever the signal that you are getting here, megahertz added with hertz, megahertz subtracted with hertz, both are in megahertz only. So these type of signals are called as very high frequency signals. So by using this process of modulation, we are actually converting a low signal to a very high frequency signal, or a baseband band limited signal to a band pass or a modulated signal. So bandwidth before modulation is FM. So at this low frequency level, the bandwidth happens to be FM hertz, maximum frequency of the message signal. But once you do the process of modulation, the bandwidth happens to be the difference of this FH and FL. So this value will become 2 into FM hertz. So that is how the bandwidth is going to change after modulation process. So when you talk about the systems, these are 4 important systems: Hilbert transformer, ideal low pass filter, ideal band pass filter, and a modulator. So simple process of modulation is to convert a low frequency baseband band limited signal into a very high frequency or a band pass signal. Okay? So just keep these systems in mind. Now, if you see the questions that are coming from this area, I have taken these questions as reference from other DISCOM examinations conducted in various states, and also EC paper questions related with the DISCOMs of our states. So you will not get a question which is very difficult, that is for sure. It will touch only the basic points. So these are some questions which you can expect from this area. So the Fourier transform of a signum function is given by. So I have given you the transformation. You should not think about it. Immediately mark, that's all. SGN of t transformation is 1 by j into pi f. So if you are expressing in omega, multiply with 2 and divide with 2. So it automatically becomes 2 by j 2 pi f is j omega. That's all. So your answer should be 2 by j omega. Okay? Next. Now, by modulation, what you are actually doing? Frequency spectrum is translated to other frequency band, time domain signal is shifted, signal is made linear and band limited, signal is distorted. So only possible choice is A. So frequency spectrum is translated to other frequency band. So which frequency band to which frequency band? We are actually converting from low frequency band to very high frequency band. That's all. That is what the modulation process is carried out. Next, what is the bandwidth requirement of a telephone channel? So when you talk about a telephone channel means what? Is it the voice signals or the speech signals that we are talking or not? Now whatever the frequencies that I produce when I talk, they are nothing but speech signals or voice signals. Now the frequencies of these signals are varying from 300 Hz to 3.5 kHz. So these are band limited to 3.5 kHz, but as per ICC standards, these are band limited to 4 kHz. 3.5 kHz is the edge actually, but as per this ICC standards, International Committee on Communication, we take it as 4 kHz. So that itself will become the bandwidth of speech signal. So telephone signals are nothing but speech signals. So your answer should be 4K. Very, very important standard bit. Now what is the bandwidth of the signal shown in the figure below? So you can observe here, whatever the value of FL is shown and whatever the value of FH is shown, both are in kilohertz range only. That means definitely whatever the spectrum he is representing is a spectrum of band pass signal. Okay? So when you take a band pass signal, the value of bandwidth will be always the difference of this FH and FL. So the value of bandwidth in this case would become 530 kHz minus 50 kHz, which will be 480 kHz. Finish. So your answer should be 480 kHz. So these type of questions you can expect in your papers. These are questions coming from fundamental signals and systems part. Is it clear? So I hope you are following all these points. This is how you have to prepare. Whenever you see the question, you should be in a position to directly answer that question without any doubt. Okay? because the time is very much limited, less than a minute or maximum 1 minute. So you cannot spend more time on doing that and thinking about that. Most of the questions will be formula based, or these are all direct statements related to fundamental transformations. So easily you can answer these models. Okay. Now let us go to the next part. It is amplitude modulation schemes. Just give me a second. So what are these amplitude modulation schemes, and how we can expect some questions related with this area? Right, Himanshu, Naga, Muri, good, you are responding. So try to understand these things. These are very good questions. You can easily follow them, not very difficult. So let us now go through this amplitude modulation schemes. So what are these standard amplitude modulation scheme? The different parameters we have. Okay. So here, when you take a standard AM, so standard AM signal is represented by AC into 1 plus Ka m of t whole multiplied by cos 2 pi fct. So this is the modulated signal expression, first point. Okay. Now here the value of modulation index mu is given by Ka into mod of m of t max. Maximum possible magnitude of message signal multiplied by Ka is the value of modulation index. And when you take single tone signal, this mu will be equal to Ka into Am. And other than this, mu you can also determine from time domain waveforms as Vmax minus V minimum divided by Vmax plus V minimum. Okay. And when you supply more than one single tone signal, the formula we are having is mu t square will be equal to mu 1 square plus mu 2 square plus so on. So based on that you can find mu t. Now these are all the formulas which we have related with the modulation index. Because in standard AM, most likely chances are getting question on modulation index. Okay. Now most of the time modulation index values will be between 0 and 1. So if it is between 0 and 1, we call it as under modulation. And if it is equal to 1, then we call it as perfect modulation. And if the value of mu is greater than 1, we call it as over modulation. So these are three different values of mu. Based on that we are giving these names. So just remember these formulas for modulation index. Okay. So this is your modulated signal expression. Now when you supply a single tone signal, most of the times 99% cases it will be with a single tone signal only. So m of t we write as Am cos 2 pi fmt. So your modulated signal expression in time domain will be AC cos 2 pi fct plus you will have AC mu by 2 into cos 2 pi fc plus fmt, which is representing upper sideband, and AC mu by 2 into cos of 2 pi fc minus fmt. So whenever you do transmission of standard AM, these are the three components that are getting transmitted: carrier, upper sideband and lower sideband. Okay. So these are the different modulated signal expression when you take m of t as a single tone signal. So once you have this, what is the total requirement on power? So total power requirement is Pc into 1 plus mu square by 2. So this is a formula you have to use to determine the total power required for transmission. Power required by carrier is AC square by 2 watts. Okay. So when you supply more than one single tone signal, then the total power requirements would be equal to Pc into 1 plus mu t square by 2. Already I gave what is mu t square. Mu 1 square plus mu 2 square, like that. Depending on number of mu 1, mu 2 you have, you can extend that. And bandwidth is always equal to twice the maximum frequency of message signal in hertz. And the value of modulation efficiency or power efficiency is mu square by 2 plus mu square. Okay. And if you have more than one single tone signal, this value we can express as mu t square by 2 plus mu t square. Finish. So these are all the formulas that you can use when you are dealing with a standard AM or a conventional AM. Modulated signal expression for any case, for single tone signal total expression, power, bandwidth and modulation efficiency. So the value of modulation efficiency you take for even mu equal to 1, it becomes only 1 by 3. That means the major disadvantage here is most of the power is utilized on carrier rather than transmitting of sidebands. Your message will be present only in sidebands. So you are wasting more power on carrier rather than transmitting your message. That is the main disadvantage of using standard AM. So if you deal with the modulators, we have square law modulator, this is the name. Just remember the names, that is enough. Only one modulator we have. It is square law modulator. And if you take demodulators, then we have a square law demodulator, then synchronous detector, and last one is an envelope detector. So these are 3 demodulators that we use. Okay. Yeah, EC also we will try to provide. Sure, Sunita, we will try to accommodate that also. And ESC papers, I don't think that much preparation is also required. Just refer to the fundamentals because these questions will be straightforward for you. No need to go into too much of depth and waste your time. Try to see the total syllabus is covered. That is more important for us. You need not go in depth, but you have to cover the entire part of your syllabus. That should be the major motto. Okay. So when you take these 3 demodulators, most likely the question, if it comes, it will be from the envelope detector part. So here the discharging time constant RL into C should be well within the boundary of 1 by FC and 1 by FM. That is one important point. And to avoid diagonal clipping, the value of RL into C should be less than 1 by 2 pi FM into root over 1 minus mu square by mu. That's all. So these are the 2 important points you have to remember with respect to an envelope detector. The discharging time constant of an envelope detector, you have to take care of these 2 points. Numerical point of view, these are the only things that he can ask. And when you take a synchronous detector, if you don't maintain phase synchronization, whatever the phase that is used at the transmitter and the phase that you are generating at the receiver should be one and the same. If you don't use that, then there will be a problem. So whatever the output that comes at the low pass filter will get proportional to cos theta, and the power at the output will be proportional to cos square theta. The theta is nothing but phase mismatch. So if you have a phase mismatch of 45 degrees, output amplitude will be proportional to 1 by root 2 and output power will be proportional to 1 by 2. So original power gets reduced by 50%. Okay. So these are the points you need to remember with respect to these demodulators. So all these points are related with standard AM. Okay. Now if you take the other two modulation schemes in amplitude modulation, we have a DSBSC, double sideband suppressed carrier, and we also have single sideband suppressed carrier, SSBSC. So the name itself tells, in double sideband suppressed carrier, we don't do transmission of carrier, we do transmission of only upper sideband and lower sideband. So here when you take SSBSC, here we do transmission of only one sideband. That means either lower sideband or upper sideband are transmitted. And the modulated signal expression is simple product of message with carrier. So your carrier is AC cos 2 pi FCT. That's all. And the total power required for transmission is power taken by both upper sideband as well as lower sideband. So it is represented as AC square by 2 into power of the message signal PM. And the value of the modulation efficiency reaches 1 or 100%. And the value of bandwidth stays at 2 into FM hertz. Okay. So what is the major advantage you are getting in DSB? The modulation efficiency is becoming 100%. Now when it comes to SSB, here we use this Hilbert transformer. So it is like AC by 2 m of t into cos 2 pi FCT. It can be minus or plus depending whether you are doing a transmission of upper sideband or lower sideband. AC by 2 m cap of t into sin 2 pi FCT. So that m cap of t, whatever you are substituting here, is nothing but Hilbert transformer. So that Hilbert transformer system which I told earlier, we use this in SSB system. Okay. And the total power you require is half of the power taken by DSB. So it will be AC square by 4 into PM watts. And because you are doing a transmission of only one sideband, the value of bandwidth would be automatically becoming F max, maximum frequency of your message signal. And the modulation efficiency will be 100%. So this SSB has all the advantages. Your requirement on power is minimum, your requirement on bandwidth is minimum, and modulation efficiency is 100%. So SSBSC is the practically used modulation scheme. Practically used modulation scheme. So where you use this SSBSC? SSBSC is used in transmission of speech or voice signals. So that is the reason the value of bandwidth of a single speech signal we are limiting to 4 kilohertz. So this is practical application of your amplitude modulation schemes. So among all the modulation schemes, we give preference to SSB SC modulation scheme. Is it clear? So this is how you have to understand these points. So I have tried to cover AM system along with the expressions, power, bandwidth requirements and different modulators, demodulators used. Then I covered DSB and SSB systems. Comparing all the three schemes, the best modulation scheme among amplitude schemes is only SSB because it requires minimum power, minimum bandwidth requirements. Modulation efficiency also reaches 100%. So these are the points you need to remember with respect to AM techniques. Now see these questions, small questions which you can expect in your exams. Okay? A 360 watt carrier means, what is the meaning? The power taken by the carrier is 360 watts. Is sinusoidally modulated means single tone modulation by a message signal having frequency of modulation indices. So you are given mu1 as 0.6 and mu2 as 0.7. Calculate total power required for transmission. So what is the formula we can use? PT will be equal to PC into 1 plus mu t square by 2. Finish. Straight away you have to get into this. So what is mu t square? This will be mu1 square plus mu2 square, means 0.36 plus 0.49. So it will be 0.85. Okay. So what is this PT here? It will be 360 into 1 plus 0.85 divided by 2. You can do the calculation, that's not a big deal. Easily you can do it. Okay. Next, total sideband power. So how will you get the total sideband power? Power taken by both the sidebands. So as you have calculated total power, from this you subtract the carrier power. So whatever the remaining power that is coming is the total power taken by sidebands. And what is modulation efficiency? So modulation efficiency is the ratio of the power taken by sidebands to total power required to transmit the signal. So you have the sideband power, you have the total power. Take its ratio, multiply it with 100. You will get modulation efficiency in percentage. Finish. So I have tried to cover all the formulas in one single question so that it will be beneficial for you to understand. Okay? Let us see one more question. An AM transmitter radiates 9 kilowatt with the carrier unmodulated and 10.125 kilowatt when the carrier is sinusoidally modulated. So what is the meaning in this statement? When there is no message, power taken by carrier is 9 kilowatt. And when you are considering a transmission with message, the power taken is 10.125 kilowatt. What is he asking for the first part? Calculate the modulation index. So this 10.125 into 10 cube PT equal to PC is 9 into 10 cube into 1 plus mu1 square by 2. In place of mu, I am substituting mu1, that's all. So you can cancel out these terms and find mu1. You will get some value, okay? That is done. That is the first part. Now what is the second part? Calculate the modulation index, that is done. If another sine wave corresponding to 40% modulation is transmitted simultaneously, what is the total radiated power? So you have mu1 value obtained and the value of mu2 is 40%. 40% means 0.4. So what will be mu t square? This will be mu1 square plus mu2 square. So what is the total power? Power taken by the carrier is 9K, that remains same, into 1 plus mu t square by 2. Finish. In place of mu t square, you can substitute this value. So this is how you can calculate the total radiated power. Yeah, very good, Tej. It is 513. I am not substituting the values. You can do it from your side. It's not a big deal. Okay, is it done? Let us see one more question. An AM signal is represented mathematically. So here it is given as AM signal. AM signal means standard AM or a conventional AM. What are the values of power and bandwidth? Generally, sketch the spectrum is only for your understanding. Most of the times question will be on power and bandwidth. So what is the frequencies of your message signal? This is 1500 Hertz and this is 3000 Hertz. So when it comes to bandwidth, what would be the bandwidth? The bandwidth requirements will be always twice the maximum frequency of my message signal. So my message is combination of two single tone signals. One is 1500 and another one is 3000. So the total bandwidth will be 6000 Hertz or it would be 6 kilohertz. Finish. That is how you can tell the bandwidth directly. Now what about the total power requirements? If you write this expression in standard format, take 20 common, AC into, you will have 1 plus 2 by 20 is 0.1 into cos 3000 pi t plus 10 by 20 is 1 by 2 or 0.5 into cos 6000 pi t. Finished. Whole multiplied by this carrier, which is cos 2 pi fct. Now is it in standard format or not? Now he is asking about power. So what are the values of mu1 here? It is like 0.1 and value of mu2 is like 0.5. So what will be your mu t square? 0.01 plus 0.25. So value becomes 0.26. So what is the total power now? AC square by 2 is power taken by carrier into 1 plus mu t square by 2. That's it. Substitute all the values. Now amplitude of the carrier signal we are having as 20. So 20 square 400 by 2 will be 200 into 1 plus 0.13. So you will have 200 into 1.13. So 113 into 2, 226 watts. That's all. No need of using any calculator also. You can do it very easily. So this is how you can tell directly by looking into the waveform what is the total power and what is the bandwidth required for transmitting the signal. So these type of questions they are likely to come in your exams. So it is basically using these formulas. So whenever they deal with analog communication part, okay, it can be standard AM or it can be even angle modulation, means FM or PM. Most of the times the concentration will be primarily on calculation of power. What is the total power requirements for transmitting your modulated signal? And the second one will be what is the bandwidth requirements. So this will be the primary choice for any examiner. So because for your branch anyhow communications is given for the first time, so they will definitely concentrate on this. They will concentrate on calculation of power and calculation of bandwidth. Now after this only the remaining part of the questions can come. So that will be the names of modulators and demodulators. Names only, no need to go through all the settings, all these things. I don't think they can go that far extent. At least remember the names, because chances of giving questions like match the following is also possible. List 1, list 2 they may ask. List 1 is different modulation schemes. List 2 is different modulators or different demodulators for those schemes. So you have to match them. So these type of questions are very famous in ESC prelim examinations. So if you look at these ESC papers, especially the objective papers, they are straightforward questions, formula based questions, simple questions. You have to read the question, answer it within a minute, not even complete 1 minute, within a minute. So the same approach is there in your DISCOMS exams also. So most of the questions that you can expect are these models only. So basic model is first calculation of power bandwidth, and then related with modulators and demodulators, names. And like I told, envelope detector is there. So what is the most important part in that envelope detector? Discharging time constant. So what are the conditions on that? So those 2 points, if you understand, that is sufficient enough. So at this junction, don't try to waste your time in analyzing the total subject and understanding. That is not right now. That should be done at a different level. So because the time is very limited, what you can do is do this type of preparation. So whatever I have taken today is just another session. I concentrated on 2 topics. What are the different signals, their transforms, different systems, their transforms. One question you can expect from that area. And then amplitude modulation schemes. 3 schemes are there: standard AM or conventional AM, then double sideband suppressed carrier and single sideband suppressed carrier. So these schemes, what are the different types of questions that you can expect? We have discussed that part. So this is how you have to understand your topics and go through them. So I thought of discussing frequency modulation as well, but the time is not sufficient. I think the session is only up to 8 o'clock. So I will try to take one more session, maybe at the later time, where I can discuss angle modulation schemes and digital communication part. That will be a better part for you, because if I just go through all the things in one go, it may not be easier for you to understand. Okay. Actually, I prepared for that also, but right now I am not taking it. So don't worry, I will try to plan another session so that we can cover on that part. So these are our courses. Just let me go through these slides also, it will be done. So we have pre-recorded videos in all the streams. So those students who cannot attend our offline classes or come to the branch and study, they can also go through these recorded videos. So this is like studying in your free time. So whenever you are free, some students will be there, or some candidates will be there who are working professionals. So for them also this will be very, very feasible. So you can do your study at any time. You can just open our app and go through all the videos that are there. So this is the pre-recorded videos for particularly your examination. Okay. And then we also have our classroom coaching taking place at Hyderabad, Kottapet branch. So we have started these sessions on 19th June, and some more batches are going to start. So if you are interested, you can contact us. And we also have some mock tests going on for all the branches and all the subjects. Individual subject mock test will be there, and grand mock test also will be there. So if you have already done your preparation, just want to judge yourself, you can also go through this test series. And the classroom coaching and online classes. So online classes is like a predefined schedule, like we have a 2 hours or a 3 hours or a 6 hour slot per day, depending on the time. So during that time you have to attend the class. Okay. So that is like online. And the first one which I have discussed is pre-recorded, that is at your ease. Whenever you want to see, you can see and study. But this you have to attend at a specific time. That is the online part. So we have online as well as classroom coaches, coaching study. So whichever is preferable for you, if at all you want to join, you can contact our branch managers. They will assist you in every aspect. Okay. So that's all from my side. Thank you very much for giving this opportunity, and I wish you everyone a very best. Try to build very strong fundamental and write your examination with full confidence. That is very, very important. Thank you.